Bismillahirrahmanirrahim. Hello everyone and good evening. I hope you are all well. What's up? What's the news? Can you hear me? Very good, very good. So, in continuing our discussion about distributed system, I think we talked about parallel computing last session. Let me to adjust the zoom of this slide, okay, so you can see it correctly. Is this the last slide we talked about in last session? Is this the last slide we talked about it last session? Okay. So, we compared two different systems, parallel computing and distributed system. Different system, I don't know really they are different or not. We talked about the architecture and parallel computing and we had a discussion about how big problems can be broken into smaller problems, and in parallel computing each machine is responsible to solve its sub-problems and how to gain and gather the results to calculate the final result. So, my last question was that, you know what is the definition of distributed system, and also you know what is parallel computing or parallel system. So to you, if we consider parallel computing as a distributed system or not, what do you think? What is your idea? Do you think parallel computing is distributed system? Mr. Ahmed Khalaf, yes. Mr. Ziauddin Faiz, we can say yes. And again, yes. Okay. So, before I explain about it, I want to speak about this slide. Did we have a discussion about this slide? Okay, so look at this picture. I want to talk about the main difference between parallel computing and distributed computing. It's about architecture. It's about architecture of the system. I want to say that they have, parallel computing and distributed computing, They have both similarities and differences. They are similar in principles. They are similar in principles. What were the principles of distributed system? Can you remember the definition? Can you define what is a distributed system? I want to find the main principles. What is distributed system? Collection of independent computers, and users think they are working with a single coherent system. Yes, exactly. It is the definition of distributed computing or distributed system. More exactly, where is this slide? Here. A distributed system is a collection of independent computers that appears to its users as a single coherent system. There are two main concepts. The first concept is a collection of independent machines or computing machines. So this is the first principle, and we interconnect these machines through a network. We use a network to connect these independent machines. Also, users must think that they are working with a single coherent system. Users must think that they are working with a single coherent system, not a distributed system. So, in parallel computing, as you know, there are many different processors. Each processor can be assumed as a machine, computing machine. They are connected through a network, and a user can see the system as a whole system, as one system. I mean, if you want to solve a very difficult and heavy problem that needs a huge calculations, you are using a supercomputer to solve your problem. But you think you are working with a single computer, with a single powerful computer. So they are similar in principles, parallel computing and distributed computing. However, in distributed systems, machines are connected through a network. That is, while in parallel computing, machines are usually, not always, are usually connected through a shared memory. Look at this picture. In this picture, you can see that parallel computing has many processors. They are using a shared memory. There is one shared memory. The memory is shared among all processors. But in distributed computing, each processor has its dedicated memory. So it is the main difference between parallel computing and distributed computing. In parallel computing, usually, not always, usually there is a shared memory for all processors. Got it? Well, the other main difference between parallel computing and distributed system is about scalability. Scalability. Do you know what does it mean, scalability? No, no. Mr. Noir Hamid. No, it's not. It's not the definition of this scalability. If we can easily add many new nodes or many resources, it is about expandability. It means we can expand our system. Expanding is different from scalability. No, it's not correct, Mr. Ziauddin. We can say it's increasing the resource with not affect the performance. No, it's not. It's not. It's not the correct. If we increase the input or resources, so what will happen about performance? Not affect the performance, or to better say, I'm waiting, will not affect, no, will not decrease the performance, will not decrease. Okay, it's the correct definition. So, no, it's not safe. It's not safe. In some situation, however, you may add some resources and the performance may increase in some situation. Okay, so it affects on performance. Okay. So I repeat the definition. With increase in the input of problem, for example, increasing in resources, the performance is not decreased. It's scalability. So, what do you think? Which one is more scalable? Which one is more scalable? Distributed computing or parallel computing? Or if they are the same in scalability, in terms of scalability, what do you think? Which one is more scalable? Yes, you correctly guessed. Why distributed computing is more scalable? Why distributed computing is more scalable compared to parallel computing? What's your reason? Why? because it is connected to network, because increasing the resource, because in distributed computing it is easier to add new resources. Why? We have network, and adding new resources to the network is easier. But in parallel computing, where we are using a shared memory, you know, when we have a shared memory and we have many processors, they can communicate with the memory through a bus. Do you know what is bus in computer? Bus. For transmitting data, transferring data. Okay. Yes. We have a bus, and processors use this bus to connect shared memory. When we have a shared bus here, okay, so by increasing the number of processors, what will occur? We have a shared memory, we have a bus, and we want to add some processors. What's the problem here? I repeat my question. Assume we have a system containing many processors. In this system, we use a shared memory. So processors communicate with shared memory by using a bus. If we want to add more processors to the system, there would be a problem. What's the problem? Scalability. Okay, we talked about the scalability. We are studying scalability on parallel computing. We are looking for some reasons. Your friends says that distributed computing is more scalable. Why it is more scalable compared to parallel computing? Okay, I repeat. Firstly, I asked you which one is more scalable. More scalable means by adding new resources, the performance is not decreased. You said distributed computing. I said, okay, your answer is correct. Distributed computing is more scalable than parallel computing. But why it is more scalable than parallel computing? Why parallel computing is less scalable? Why adding new resources to parallel computing is more difficult? Why? Yes, because of shared memory. But why? Shared memory affects something. Say me, tell me what is it? Why shared memory makes parallel computing less scalable? Why shared memory in parallel computing makes it less scalable? Mr. Ziauddin, why we can say that parallel computing have a fixed number of processors? Why it's difficult to add more processors? Why you can't add more processors easily? What's the problem? Synchronization? No. What do you think? What do you say, Mr. Ahmed? Such systems are increasingly available these days. Yes, I know. It's okay. But answer my question, please. Answer my question, please. Okay, I will say. I will say. Okay. Pay attention. I said in parallel computing we usually use a shared memory. We usually use a shared memory, and all processors use this shared memory. So, how processors can use the shared memory in parallel computing? I said they can use and connect to shared memory through a bus. So, when we have a bus in our system, adding new processors to the system will increase the traffic of data transferring in bus. The capacity of the bus, the bandwidth of the bus is limited. We cannot increase the bandwidth of the bus. So it is bottleneck. It is bottleneck. Do you know what is it? What does it mean, bottleneck? In Arabic, you say أنقذ زجاجة or something like this. Bottleneck. Yes, أنقذ زجاجة. The bus has this problem, bottleneck. So if you add new processors, the bottleneck will occur, so the performance is decreased, and that is, parallel computing is not scalable as the distributed computing is. Yes, exactly, Mr. Hossein Reza. Yeah. So, I talked about differences. There are two main differences. The first one was about memory and architecture. In distributed computing, each machine has its dedicated memory. In parallel computing, we usually use a shared memory. And the second difference is about scalability, and we talked about it, and we said that distributed computing is more scalable because adding new nodes, adding new machines to this system is easier than parallel computing, and it was about bottleneck in bus. So, what is the final answer? Is parallel computing and distributed computing the same? Or can we assume that parallel computing is a distributed computing? We said that they are similar in principles. Also, we said that they have differences. Yes, to me, there are many different ideas, okay, but to me, it's very difficult to completely distinguish between these two systems. So, we can say that parallel computing is a type of distributed computing. Okay. And what are the main goals of distributed systems? What are the main goals of distributed systems? There are four main goals here. The first one is about availability, resource availability. The second is about transparency or şeffafiyet. And the third one is openness. The last one is the scalability. We talked about scalability. When we say these are the main goals of distributed system, we mean that a good distributed system must be transparent, must be open, must be scalable, and their resources must be available. If a distributed system can provide these goals, then we can say it is a good distributed system. But firstly, I want to ask you that what do you think? Which one is more important? Please guess. Don't search on internet, okay? Please guess. Which one do you think is more important that a distributed system must have? Which one is a must for distributed system? Which one is a must for distributed system? Which one is more important? Which one do you certainly expect that a distributed system must have? Scalability, availability. The other students, guess what do you think? We will talk about each one in detail. Okay, I know you don't know, you may don't know what does it mean, openness or transparency, but please guess. Scalability, because the resource is grows, and the first one I think, okay. In fact, the most important goal of distributed system is resource availability. Why? Because at first we expect a distributed system provides a full availability for its resources. When you want to use a distributed system, it means you want to use its resources, and you expect firstly to see the resources are available. So it is the most important goal of distributed system. So I repeat, the most and the main goal of distributed systems is that users can easily access to the resources, to the shared resources in distributed systems. What I mean by shared resources is everything that are shared in distributed systems. For example, printers, computers, and I don't know, storage spaces, data, files, web pages, and everything that we can see them as a resource. So, availability of shared resources is the most important goal of distributed system. It is sensible to use shared resources in distributed system. It is logical. Why? Assume that you are working in an office. Okay, there is a room, and you and your friends are working in this room, in this office. For example, you have 5 friends, and so you are working in this office. Which option is more logical? Option 1, we can buy 5 printers for you. Each person has its personal printer. Option 2, we can buy only 1 printer and share it for you and your friends. Which one is logical? Yes, so sharing resources is economic, is more economic. It's logical, it's sensible. That is why we use distributed systems. That is why we use shared resources, because it is economic. However, having many shared resources and many users in distributed system may raise some problems or some issues. The main issue is about, what do you think? The main issue in distributed systems, when we use many shared resources and we have many users, is about what? Yes, Mr. Ziauddin, it's about security. It's about security. When we have many users and we have many shared resources, the security would be a very important issue, because there are many shared resources, for example, data, information, and we must prevent unauthorized access to the information. It's about security. Do you think what is اضطراب سمع in networks, some hackers may listen to the network that you are using to transfer your file. For example, you are sending your private files to a server, okay? So between you and server, there is a communication link. If someone, we say hackers, listen to this link, they can steal your information. They can steal your information. Or if hackers can sign in to the server, they can steal or steal information. So the security is very important in such systems. One way to make a communication link more secure is about encryption. Encryption. Do you know what does it mean, encryption? You can encrypt your data. So if someone see your encrypted data, they cannot find what does it mean. Okay, it's encrypted. So encryption and encrypting algorithms are a solution to make a communication link more secure. Well, so it was the main goal of distributed system, resource availability. It means you firstly expect each distributed system provides you its resources available. The second one is about transparency. Transparency means şeffafiyet. So it's about hiding unnecessary information. Hiding unnecessary information. It's about transparency. Not everything. It's not about hiding everything. It's about hiding that must be hid. It's about hiding that must be hidden. Sorry. So, for example, when you are using Google OneDrive to make a backup of your data, okay. So you upload your information on Google server, but you don't know where is located. You don't know where servers are located. Do you know? No, you don't know. It's transparency. It's location transparency. You don't know anything about the location of Google servers because there is no need to know. There is no need to know about their locations. So transparency is another goal of distributed system. We will talk about it in detail later. The next goal is openness. What does it mean? What do you think about openness? What is an open distributed system? What is an open distributed system? Protocol, any user can use a resource in a system. No, is to make it easy for users to access remote resources and to share them with others in a controlled way. Somehow, I think its ability to add new services. Exactly. This is the meaning of openness. To add new services. To add new services to the system. In an open distributed system, we must provide services based on standard protocols. Each protocol says about syntax and description of the service. So, syntax and description of services must be clear, and services must be provided based on these protocols. For example, in distributed system, if you want to transfer file, if you want to upload a file to a server, for example, you want to upload your homework on Dersa website, or you want to download the PDF from Dersa website, upload or download. It's about transferring files. Which protocol is used? FTP, File Transfer Protocol. It's a standard protocol. So, if services in distributed system are based on standard protocols, this system is open. It means if we want to add new services, it's easy for us because all things are clear. All things are clear. We know what should we do. So it's openness. Clear? If I want to give you more explanation, I can say that IDLs. Do you know what does it mean? Ideal. What is it? Ideal. IDL. Interface definition language. It's for defining interfaces. The syntax of services is defined in IDLs. For example, which functions are there, and each function have how many parameters, and what will be return value, and also about exceptions. Ideal is a good tool to provide services as a standard protocols. So to have an open distributed system, we must use such ideals. For example, so suppose we are using this video conference created by Adobe Connect. It's from Adobe Corporation. Okay, so in this application, it's a distributed system. We can use to share slides. You can hear me, I can hear you too, and you can use a chat service here. We have something for chatting, and if we want to add a new service for transferring files between students, it would be easy because we know what we should do. I mean, the Adobe Corporation can add this new service easily to this application, to this distributed system, because protocols are clear. So it's about openness. And the last one is scalability. We talked about scalability a lot, and you completely know what is it, scalability. By adding new resources, the performance is not decreased. For example, you want to add new shared printers, so the performance of the system must not be decreased. It is the last goal of distributed system. Clear? Okay, and now we want to talk about these goals in detail. Availability is very clear. So the second one is transparency. Again, remember the definition of distributed system: a collection of independent computers in a way that users can see the system as a single coherent system. Yes. The second part of this definition is about transparency. If users think they are working with a single system, it means the system is transparent. Again, if users think they are working with a single system, it means the system is transparent. So, transparency have different forms. In this table, you can see different forms of transparency in a distributed system. For distributed transparency, you can provide these forms of transparency. The first one is access transparency. What does it mean, access transparency? As you can see, look at the description: hide differences in data representation and how a resource is accessed. Hide differences. If you pay attention to this description and other description, the first word is hide. Hide differences, hide where, hide. So transparency is about hiding. When we say access transparency, is about hiding how to access to the data or resource. I want to give you an example. For example, in distributed system, some computers may use Microsoft operating system, and some other may use I don't know, Apple Macintosh, and a student uses it mobile Android operating system. So there are many different operating systems. Each operating system has its policies about file naming, file formats, for example, and but when you use this system, you do not be aware of this fact. For example, you don't know what is my operating system. You don't know anything about my file naming system. You don't know about my file systems, for example, FAT, NTFS. You don't know, because there is no need to know. It is access transparency. I share my PDF file, but you don't know how you can access it. You can access to this file, but you don't know how. So it is access transparency. Clear? The second one is about location transparency. It means there is no need to know where is the location of the resource you are using. You are using Google OneDrive, but there is no need to know where the server is located. So it hides the location of resource. It is location transparency. It is location transparency. You are using Google to search something, but you don't know where the Google servers are located. You don't know. It is location transparency. Okay. The third one is migration transparency. Migration means مهاجرت. مهاجرت, okay. It hides that a resource may move to another location. For example, you are using Google to search something, okay. So you connect to a server of Google server, for example. Tomorrow Google decides to move its server to another location. Then when you again use Google to search something else, you don't be aware of it. You don't be aware of it. The resource changed. The location of the resource has been changed, but we don't know. It's migration transparency. Okay. Is it clear? If you want that I give you more explanation, please tell me. Users may be located in different continents. It's about location transparency. If we say users are resources, so it's about location transparency. But migration transparency is about changing the location of resources. For example, you are using online banking, okay? So you have an account to a bank, and this bank gives you some online services based on internet. Today you want to transfer money between your accounts. So you open your laptop, you go to the website of the bank, you sign in to your account, and then you transfer money between your accounts. Okay, so in this example, you don't know where the servers are located. Okay, it's location transparency. For example, the bank has two main servers, one in Baghdad and the other in Najaf. Okay, You don't know this fact. It is location transparency. Tonight, the bank decides to move its server from Najaf to Karbala. Okay, so the server moves to Karbala. It means they create new server in Karbala and close the Najaf server. Tomorrow, you use your online banking again, but you don't be aware of this move. You don't be aware of this location migration. It's about migration transparency. Okay? Very good. How about relocation? Relocation hides that a resource may be moved to another location while in use. Relocation is similar to migration, but there is a main difference. While in use. While in use. While you are using a resource, the location of resource is changed and you don't know. You do not be noticed. You are not noticed. Okay? You don't know about this fact. It's relocation transparency. For example, when you are using online banking, okay, this time you are in a car. You are in a car and you open your laptop and you are connected to the internet by mobile data. The car is moving, and when the car changes the zone, it means the car leaves one zone and enters the other zone, the zone of mobile phones. So the antenna of mobile is changed, but you are using your online banking and you are not noticed. You don't know this fact. It is relocation transparency in distributed system. Clear? How about other students? It was clear for all students? Okay? Well, replication. What does it mean, replication? Do you know the meaning of replication? Replication. Yes, it's about copy. Do you think Google has one server or it has many servers to serve single server? I think I disconnected for a few seconds. So, I was talking about replication. I asked you, what do you think? Do you think Google is using only one single server to provide services to all people in the world, or it has many servers across the world. If Google uses only one server, what will be the problem? The problem is again bottleneck. Suppose hundreds of millions of people want to access to Google server. If it is only one server, the bottleneck is occur. It cannot provide people of the world a good service. So Google has many servers in different locations, in different continents, in different countries to provide a good service. Okay. These servers have the same data. The server have the same data. It means the data is copied on different servers. So when you are using Google to search a sentence or to query something, you don't be aware of this fact. You don't know that Google has many servers, and you don't know you are using which server. Okay, it's about replication. The data is replicated, but you don't know. What you don't know. In distributed system, if we use a single server, to provide services for all users, there would be some problems. One problem is about bottleneck, because all accesses are to this server. The other problem is about what? For example, in online banking again, let me back to our example. In online banking example, if the bank uses only one server to provide services for its customers, what would be problems? The first problem is about bottleneck, because all people, all clients, or all customers must access to this server. There is only one server. It's bottleneck. The other problem is about security. Why? Because if this server crashes, then people may lose their information. The data may be lost. And it's catastrophe, in fact. And so it is logical to have some backups of data. These backups are located in different locations. So it is replication. The backups are not offline backup. They are online, and it means the other servers can provide services. They work because there are some servers, for example, in online banking, one server in Baghdad, the other in Najaf, and the third server is in Karbala. These three servers are working. They are providing services, and they have the same information, the copy of information. So it is replication. If one server crashes, the other servers continue to give services. It is replication transparency if you cannot be aware how many replication is there. Okay. And concurrency. Concurrency is something about competition to access to a shared resource. For example, in online banking example, you want to access to your information, and at the same time, other people want to access their information too. The information is stored in a database, okay? So there are different requests to access to the database. You want to access to your information, your friend, your other clients want to access their information too. There is a competition, okay? And in this competition is managed by the server, okay? You don't know about this competition. You don't know that there is a competition to access the database. It is concurrency transparency. For another example, consider there is a shared printer in your room, and you and your brother are using your computers, okay? At the same time, you and your brother want to print your document, okay? The printer is shared. So you click on print at the same time. You and your brother want to access the printer at the same time. It is competitive. Okay, it is managed, it is handled, okay? But you don't know about it. Your document will be printed. So it is concurrency transparency. And lastly, failure transparency is about hiding the failures. Hiding the failure and recovery of a resource. Again, in online banking, if a server crashes, you don't know about it. It will recover the resource, or you can get the service from another replica. So in this case, we have failure transparency. In fact, failure transparency is the most difficult issue in distributed system. Why? Why it is the most difficult? Failure transparency. We must hide the failure of a resource from user. Why it is difficult? because it is very difficult to distinguish between a dead resource and a slow network speed. It is very difficult to distinguish between a dead resource and a low speed network or communication. For example, you want to buy apple, okay? You go to the store and you buy your apple, you use your credit card to pay the money. And so you use your credit card to pay the money, you enter the amount of money you want to pay, you enter the password, and then you press the OK button. Now you are waiting. There would be two situations. The first situation is that your payment is operated on the server successfully, and once your operation is completed on the server, your payment is completed on the server crashes. So you do not receive any response. Your payment is successful, but just after completion of your payment on the server crashes. So you do not receive the response. The next situation, the second situation, is that while your payment is operating on the server is crashed. Your payment is not successful, but you do not receive any response again because the server crashes. So it's difficult to distinguish between these situations. The other situation is that your payment is in a queue of process. The server is very busy. The server is too busy, and so you must wait. But in this situation, you don't know if the server is crashed or the network is low speed. You don't know. It's difficult to distinguish. So failure transparency is the most difficult thing in distributed systems. I'm sure you have experienced some situations that you used your credit card, but you have not received any notification, and you must wait for 2 or 3 days. If your money goes back to your account, it means the operation was not successful. It failed. Otherwise, it would be successful. That is why failure transparency is difficult in distributed systems. Got it? In summary, if we can provide these forms of transparency in a system, the system would be transparent, and then users can see this system as a single coherent system. The next session we will talk in detail about how much transparency is good for our systems. So it's enough for this session, and I hope you enjoy this session. We will see each other next session. Did you see my quick note on Darsa website? I left a note on Darsa website for those students who have difficulty with English, and I said that they can attend to number 13 class, or they can also see the previously recorded sessions of this class. In that class, Mr. Aghil Ibrahim translates my speak to Arabic, so it would be easy for those students who have difficulty with English. So, yes, exactly. I told you my email address in this slide. The first session, I talked about myself, and this is my email address. And also, please note that it's important that mention your complete name and your course code, 13, 12, or 11. It's very important to mention this code. Okay, have a good night and Khuda Hafiz.